I am Professor N.B. Hulle from G.H. Raisone Institute of Engineering and Technology. And in this particular example, we will calculate the value of the current I needed in the circuit to have a flux of that is 1.8 milliwebers in 2 centimeter air gap, that is this air gap. First, I will sort out the given data here, and then we will work out on the remaining things. Here in this case, number of turns are given, that is n is equal to 710 turns, is wound on the central limb on this and steel frame of uniform cross section. Here cross sectional area throughout is given, which is 16 centimeters square, that is 16 into 10 to the power minus 4 meters square is the area. Calculate current required. We are interested in the calculation of the current I. In this case, the flux phi is given in the central limb, and that flux is given as it is 1.8 milliwebers, that is 10 to the power minus 3 webers. Here in this case, the flux is a phi, then this is a parallel circuit. Here the flux will be the phi by 2, on this side flux will be the phi by 2. That's why I will keep the pi by 2 value ready, otherwise I will use this value later on. Means here the flux in this particular case must be the phi by 2. Here is the flux phi. Sometimes phi is given here, in that case 2 phi will be here value. This here flux in this case is again the phi by 2 value. Now here, if we know these values, there is a flux in this particular case is a phi by 2, which is here, phi is here, and phi by 2 is here. Now here in this case, how will be the case? We are interested in the calculation of the MMF. It is very similar to the electrical circuit. No need to calculate the value of the reluctance or MMF for this path as well as for this path as well as for this path, but calculate for half of the portion for this path or maybe for this remaining path, because it is parallel magnetic circuit. That's why I will plan for half of this path or on this side of the figure. Now here in this case, again if BH curve is given in this particular case, is again the value of the relative permeability is not given. That's why we have to calculate the relative permeability, because here flux is different, here flux is different, meaning in both cases the flux density will be different. That's why I have to calculate, or we have to calculate here the relative permeability for the central limb and relative permeability for this side limb. I will start with the first, that is relative permeability for the side limb. Central limb first. I will call this as number 1, and this will be the number 2. We will calculate for the number 1. This here, the flux density for the part number 1, which is central part, or I will give the name as a central and side. It will be the better for understanding. This is central limb and this is the side limb. I will call it as C and S. For flux density for the central limb, which is phi by A. This is phi by A. Flux is given in this air gap, that is 0.2 centimeter air gap. That is, this flux is given. That's why its value is 1.8 into 10 to the power minus 3 divided by its area. Area throughout is the same, and that is 16 centimeter square. That is 16 into 10 to the power minus 4 meter square. And its value of the flux density, it is found to be 1.125. It is Weber per meter square. Now here in this case, we have calculated the value of the BC. Now read out the corresponding value. Here the corresponding value directly not available in the table. Now here it is 1.125. It is lies in between these two values. Then we will find out the difference of these two. That's why it is 1.13 minus 1.1. This value, which is equal to, if I am doing this calculation, that is if I am working on this calculation, that is 1.313 minus 1.1, which is nothing but it is 0.03. And if I am taking its difference again, this is 1100 minus it is that is 900. If we are doing this value, it is found to be, that is 200. And here in this case, what value we need, and according to that I will do the next calculation. Means we need to calculate H at 1.125, which is equal to H is available at 1.1 plus how much is the additional value I need? that is 0.025, means h at 0.025 we need. Now what we have here, from this calculation, for 0.03 variation is 200. For how much we want? 0.025 is it is I guess it is 0.025. This value will be not the 0.25, it is actually the 0.025. This is 0.25. Is how much is the variation for 0.025? If we are finding this variation, this is x, and if we are finding the value of the x here, which is 200 into 0.025 divided by, it is 0.03, and this is actually h at 0.025, which is x, and here this value, it is found to be h at that value is found 166.67. This is 166.67, that is ampere turns per meter. And if we are finding this value, which is equal to, this h at 1.1 is 900. This is 900 plus this value is 166.67. If we are calculating this total value, it is found to be 1.0667 into 10 raised to the power of 3. This is h at 1.125. And from this case, we can find out the mu for the central limb. Mu for the central limb, that is B. We have the formula B is equal to mu h. We have the formula, that is B is equal to mu h. We have the formula, this B is equal to mu into h. From this formula, mu is equal to B by h. Here B by h, how much is the B? I will just highlight. This is the B and this is the h. Here in this case, if we are working this calculation, it is 1.125 divided by 1.0667, this value, and if we are taking its ratio, its value is found to be, it is 1.054 into 10 raised to the power of minus 3 is the value of the mu for central limb. And if we know the mu for the central limb, we will calculate the mu for other part. Now here in this case, if this is first calculation, this is the second calculation. If we are finding the mu for second, we have to read out its value. That's why I need to calculate the B for side limb. If we are finding the B for side limb, in that particular case, its value of the flux is 5 by 2. In that particular case, the flux is 5 by 2. And in that case, its value of the flux is, it is 900. That is 5 by 2. Means if we are 1.8 divided by 3, means it is 900 into, this is 10 raised to the power of minus 6, this value, which is 5 by 2 actually. This is 5 by 2 value. This is B, 5 by A. How much is the area? Area is throughout same, that is 16 into 10 raised to the power of minus 4. And if we are working on this particular calculation, its value, it is found to be 0.5625. This is 0.5625. Again, its direct value of the corresponding value of the H and B is not available in the table. Again, we will use the same concept, difference of these two and difference of these two. If I am doing that, here, this is I will use another color here. This is the 0.773 minus, it is 0.45. This is minus 0.45. If I am using this difference, its difference is, it is 0.323. And here, if I am using the difference of, it is 700 minus, it is 500, its difference is found to be 200. Now what we want, I will keep the space here. I will keep some space here. And in this case, if we are working on what we need H at what? We have the H at this value. That is H is, we want H at what value? We want H at this value, which is 0.5625. H at 0.565 available at. it is available at h at 0.45 plus how much value additional we need? Additional value of the 0.1125 we need. Value at 1125 we need is here. In this case, h at 0.1125. This is 0.1125 we need. For this calculation, I will use the straight formula again here, maybe in front of this here itself. Means here for 0.323 variation is the 200, and for this much, how much? For 0.1125, how much will be the h? That is 0.1125, and this value h at 0.1125 is equal to this value, that is 0.1125 into 200 divided by this 0.323, and if I am working on this calculation, this value is a 569.6, sorry, its value is only the 69.66. This is 69.66 ampere turns per meter is this value. Now if we are calculating this value, which is equal to 0.45, at 0.45 it is founded, and for this variation its value is, it is a 69.66. It is 69.66, and the total value, in this case the total value is founded at this point, and this is at difference calculation. This it is 569.66 is the value of the h, and if we know the value of the h here, we will find out the value of the b here, or mu. Again we will use the formula, that is b is equal to mu into h, and here we are interested in the mu s, that is mu in side limb, and this mu in the side limb is nothing but b, this value, divided by h, this value, that is 0.5625 divided by this 569.66, and if we are calculating this value, its value of the mu for the side limb, it is found to be 987.43 into 10 raised power of minus 6, it is henries per meter. This is again henries per meter. Now here, this is the value of the mu for side limb, and if we know the value of the mu for side limb as well as central limb, then we are in a position to find out its value of the MMF. Now here in this case, if I am going in front of this, for this calculation here, this value, now here we are interested in the total MMF. I will come to this figure and then I will come to the remaining calculation part. Now here in this case, if I am looking at this figure, how much is the total MMF? This total MMF is equal to, MMF of the central path, that is MMF of central limb plus MMF of central air gap plus this, then MMF of the side limb, plus MMF of side air gap. This is the value of the total MMF, and this is equal to this value we can find out in this particular way. Now the calculation of this MMF for central limb, it will be phi available centrally, that is total flux, into, that is S, that is the reluctance of the central limb, plus the flux in the central limb into, this is the central air gap, that is nothing but reluctance of the central air gap, plus this is flux in the side limb. Here flux in this limb is given, that is phi, then flux on the side limb will be phi by 2, that's why it is phi by 2, into, that is reluctance of the side limb, that is S of the side limb, plus again flux in the side air gap is again phi by 2, into, that is reluctance of the side air gap. This is the total value. which is equal to, if I am going further in this particular case, if I am going further in this particular case, phi is nothing but it is 1.8 into 10 raised to the power of minus 3 into s in the side limb. That is the reluctance of the side limb, which is nothing but L divided by A into mu of the side limb. Mu of the central limb. I am talking about the central first. Plus, again this value, it is 1.8 into 10 raised to the power of minus 3 into S of the central air gap, which is nothing but L divided by, L is the 0.2 into 10 raised to the power of minus 2, L divided by A is the same, I will write the formula first, that is L A into, this is A into mu naught here, that is a plus. Here 5 by 2 its value, its 5 by 2 value is 900, this is 900. What are the calculations I am doing here? The calculation which for this is this, for this we have this, for this I am doing the calculation here, that is 900 into 10 raised to the power of minus 6 into S of the side limb, which is length of the side limb, this is for central, divided by A into mu of the side limb, plus finally this 5 by 2, which is 900 into 10 raised to the power of minus 6 into reluctance of the side air gap, which is the length of the side air gap divided by area into mu naught, that is permeability of the free space. If I am substituting all these values here, which is equal to this 1.8 into 10 raised to the power of minus 3 into length of this central limb, the length of the central limb, which is here this 20 centimeter, this length is the 20 centimeter. Now here if I am taking that value, which is 20 into 10 raised to the power of minus 2 divided by area throughout is 16 into 10 raised to the power of minus 4 into mu of the central. I did the calculation here, mu of the central we have calculated 1.054 into 10 raised to the power of minus that is a 3. Yes, it is 1.054 into 10 raised to the power of minus 3 is that value, plus the second calculation which I am doing here, this value is, it is same, that is 1.8 into 10 raised to the power of minus 3 into that value, which is length of the air gap, which is 0.2 into 10 raised to the power of minus 2 divided by its area throughout is the same, that is 16 into 10 raised to the power of minus 4 into mu naught, it is 4 pi into 10 raised to the power of minus 7. These are the two calculations for central limb, central air gap, plus I will do the next calculation for side limb and side air gap. If we are doing for that, here this is the value, which is 900, this is 900 into 10 raised to the power of minus 6 into length of the side limb. Now look at how much is the length of the side limb. If I am going here, this is 25, 25 and this is 25, means 75. Its length will be 75 centimeters, means 75 into 10 raised to the power of minus 2 divided by, this value is, where is that value? This is A is the area which is throughout the same, that is 16 into 10 raised to the power of minus 4 into mu s. We have calculated the mu s, which is 987.43. This is 987.43 into 10 raised to the power of minus 6 is that value, plus this calculation we have taken, this finally, this is 900 into 10 raised to the power of minus 6 into length of the side air gap. Now here in this case, length of the side air gap is, it is 0.1 centimeter, that is 0.1 centimeter, means it is 0.1 into 10 raised to the power of minus 2 divided by area throughout is the same, that is 16 into 10 raised to the power of minus 4 into it is 4 pi into 10 raised to the power of it is minus 7. And if we are working on all this calculation here, the values are found to be, the first value is 213.472 plus. Here this value is this this. Then here this value for this, it is found to be 1790.49. This value plus here value for this calculation, it is 427.24 plus value for this calculation, it is found to be 447.62. And if we are adding all this, we will get the total MMF as, that is 2878.82 ampere turns. And if we know its value, we have another formula for MMF. This is MMF. Now we have another formula for MMF, which is N into I. We are interested in the I, and here N is given as, I guess it is 710. This value of the N is 710, which is here. It is given as in the problem also. Means I is equal to MMF, which is 2878.82 divided by, this formula is I is equal to MMF divided by N, and here which is 710. And if we are doing this calculation here, its value is 4.05 amperes is the value of the current needed in the circuit to have that much flux in the central limb and side limb and so on. Thank you for watching this video. In the next video, I will elaborate about the second part of the magnetic circuit, which is nothing but the self-inductance, mutual inductance, self-induced EMF, mutually induced EMF and similar parameters. That's all for this video. Thank you.